Um, a very good day. My name is Babangide Ibrahim. I'm here to present um, our work, construction and application of stair box plot for exploratory data analysis. I am from Federal University, Dutse, Jigawa State, Nigeria. Okay, this is the outline of our presentation: introduction, material and methods, results and discussion, conclusion, then references. Um, for the introduction, Tukey introduced boxplot, and boxplot typically just display a batch of a univariate data set. If you look at the image in the left, is a batch display of univariate data set, where the box in the middle represent the middle 50% of the data from the lower quartile to the upper quartile, and the middle line divide the box into two, whereby the whisker line is drawn up and down, in which we have the lower fence estimate and a full face estimate. So we have different arguments in the literature based on the first estimate. I capture some of them, and they are there from the Prigge, Kimber, Carlin, Shortman, Hubert. All try to adjust and justify why should you use a particular implementation for the fence markup. And the fence markup was specifically identify consistent observation. Any observation outside the fence or below the fence, lower fence, or above the upper fence is marked as outliers. Okay, so this is some of the functionalities of boxplot, and in this age of data science, boxplots remain a very important tool for data visualization. Hence, uh, since the early age of boxplot, it has received a significant improvement. For example, McGill improved boxplot by incorporating the notch, which identify the confidence interval around the median. Also, a lot of transformation follow up for boxplot display. Like Abu Zaid proposed another boxplot for circular data. Karamala proposed a K boxplot to display multimodality in boxplot. So many limitations of boxplot were overcome, and we have a lot of new proposal of plots that are inspired by boxplot. For example, the base plot by Benjamin, by Byron, by Haynes, the bin plot by Kamstra, the raindrop plot by Barrowman. All of these plots were meant to overcome one problem or the other of boxplot. Despite all that, we come to realization that some or most of these plots could not display individual observations. Sometime in visualization we need that. So that's why the proposal in our earlier article, in another article, stair box plot. And we also observe some of the limitation of the earlier proposal, especially in proposing some of the concepts. So we come up with another concept that are very important in the construction of box plot, like this quad bin. Is just like the histogram bin, but we are very specific in this case, whereby we define our bin to be based on dividing data into exactly four. In the histogram form, we don't have a specific number of bins to draw a histogram. But in Stairboxplot, we need a quad bin, specifically divide the data into four according to the range, and we define the range very clearly there. We also have this concept of outliningness as defined in the literature. The outliningness of a point xi in X is a measure of how far an observation lies from the estimate of central point of the data, usually standardized by the means of robust scale like the median. So according to Hubert, one of our references, he redefined outliningness by defining adjusted outliningness in that form, the mathematical expression of outliningness. So we are inspired to use that definition in essence. This adjusted outliningness use a specific whisker definition, whereas here we define according to any implementation of a whisker definition of a box plot. So we have the distance of the point from the median scale over the distance of the whisker from the median. So depending upon where the point falls, if it is below the median, we use the lower whisker. If it is above the median, we do the upper whisker to define the Stairboxplot outlineness. Nevertheless, in the implementation, we also observe that we need to rescale this. We scale the SOI to SO alpha to call it a scale outlineness, Stairboxplot outlineness, where alpha is a value between 0 and 1, just for our floating control of the display. Sometimes if we come to the batch display of the box plot, we see that there is a problem. So we need this scale to adjust that kind of problem. So we have how we estimate a description of how we estimate the stair outlineness here in this page using that image. Here is the result of our convolution, the result of our work. We have a comparison between the classical box plot in the left and the stair box plot in the right. And if we look at the two plots, they all display invariant data set. In the classical box plot, you can't see all the data points. So in this here, we see the data point and the outlineness of the data point. In the classical box plot, we see all the outliers they are plotted. Also, in our implementation here, we write outliers in a dotted line, up and down. So you can see some of this, the shape of the distribution, just like how histogram display the shape. I think it's more glaringly clear than the box plot shape parameter and so on. So there is so many advantages we discussed in the paper. Also, advantage of this new plot is you see if you visualize the shape of the distribution. For example, we visualize the normal and uniform distribution here in the led by the classical box plot method. We have the visualization using the Stairbox plot, the proposed Stairbox plot, and we can see it is difficult sometimes even to identify if you are not specifically be told that the left one in the classical box plot method is a uniform, this one is a normal. You just see just the difference of center separate. But in the Stairbox plot, we can see that the quad bin in the middle are symmetrical, while the quad mill in the lower are also symmetrical. So we can see that a little shape, bell shape, we can call it, or oval shape, that demonstrate the shape of a normal distribution. While the uniform distribution, if you look at the symmetry of all the quad bins from lower quad bin up to the last quad bin. So you can see this glaring clear the difference between the two distributions. We also visualize a rainfall data to justify, we give so many analysis how this has an advantage over the classical box plot method. We see the trend in the maximum precipitation data. Also, we observe that. We also look at a low river flow data, and we give some insight into that. And conclusively, we come up with this conclusion that Stairboxplot combine the feature of the classical box plot method, the histogram we know, the dot plot functionality in a single call to a plot. So when you plot your data using Stairboxplot, you have this information all combined together into one plot. Also, we have trend analysis as described in our real-life data analysis in this article, reveal a great deal that we can take home about with Stairboxplot. Like Boxplot, also Stairboxplot is designed for only exploratory data analysis. You cannot do any confirmatory analysis as been popularly done in some cases. So this is our references, and let me say thank you for listening our conversation.